Hello everyone, welcome to Prepare Karo. Today we are going to start logical reasoning. Okay. Already we have covered various topics in quantitative aptitude and now we are starting with logical reasoning. In logical reasoning, one of the most important topic is Venn diagrams and we are going to discuss Venn diagrams only in this session. Okay, so there are four sections. One is introduction, then we will discuss two variables, three variables and four variables Venn diagrams. Okay, so let's come to the introduction part, right? Where we need Venn diagrams, what's the purpose of using Venn diagrams and why do we need them? Okay, let's say there is a survey over 1000 people. A survey is conducted over 1000 people. All right, 1000 people. The results of the survey, right, were 600 people like tea, right, and 700 people like coffee. These were the results out of the survey, right? There were 1000 people in total, 600 people like tea, 700 people like coffee. This clearly shows if you add these two numbers, 600 plus 700, this number comes out to be 1300, but the total people were 1000. So this clearly shows there is some overlap of number of people who like tea with number of people who like coffee, right? There is some overlap. So this sort of overlapping is best shown in a way of Venn diagrams, right? Venn diagrams serves this purpose. This is the pictorial representation of such a scenario of overlapping of the variables. Whenever there is some overlapping of the variables, you will need a pictorial representation in the form of Venn diagrams. Alright. So here it shows a rectangular box. This rectangular box always tells total number, right? Total number. Then there are two circles here. Why there are two circles here? Because there are two variables. One variable is t and other variable is coffee. So there are two circles. Circle A, let's say A represents people who like tea and circle B represents people who like coffee. Alright. So you will say 600 people like tea means the circle representing variable A. This circle sums up to 600. Right? This circle is totally 600 and the other circle is 700. This circle B is 700, right? As of now, we don't know the total number of people who like both tea and coffee. Also, there is one particular region, right, which you don't know. So this region is none. None is inside the rectangle and outside the circles. So this white portion within the rectangle, this white portion is none. All right. And this region, this shaded region is both. Both means the number of people who like both tea and coffee. So for this we require some other information given out of the cell. Right? So this is the overall idea. This is a brief about introduction of Venn diagrams. There could be number of variables like 3, number of variables like 4. In exams like CAT, in any of the year, the number of variables that have been asked as of now are 2 variables, 3 variables or 4 variables. So we won't go beyond 4 variables, right? So we'll stick to 2 variable Venn diagrams, 3 variable Venn diagrams and 4 variable Venn diagrams. Okay, let's come to 2 variables Venn diagrams. So there is a particular language that we have to understand in this topic of Venn diagrams, right? Let's say there are variables like variable A, capital B are the variables. Capital T represents total, small n represents none, small a, small b, and small g, right? Okay. Compare this Venn diagram with the previous one, this one, T. If I ask you here the number of people who like only T, let's say this is the region small a, this is the region small b, and the central region is small g. This one is small g, right? And this is right, none, n. Okay, that's a total capital T. So if I ask you here, the number of people who like only T, right? Who like only tea means the people who does not like coffee but like tea, only tea. This reason A, right? So here also we can write the same way. If I ask you the number of people or the number of uh, observations that falls into the circle A, right? Capital A is small a plus g. But if I ask you only capital A means we have to exclude G. So only capital A is small. Alright. Same way, capital B is small b plus G. But only capital B means small b. B is equal to small. Alright. If I ask you A and B, A and B. So A and B means the intersection. And means intersection, so the region that belongs to both A and B. There is a particular region that belongs to both A and B, and that region is small. Alright. Same way, if I ask you none, that is clearly small n. What about total capital T? This is small a, small b, small g, and none. Alright. So if you look here, in total, the number of regions is 4. In the total, the number of regions is 4, small a, small g, small b, and small n. Number of variables is 2, number of regions is 4, right? So, number of variables, variables means capital A and capital B type, right? Number of variables is equal to 2 and number of regions is equal to 4. Number of regions. Which regions we are talking about? Small a, small b, small g, and small n. These are the 4 regions, right? Okay. After this, if I ask you exactly 1, what does this exactly 1 means? Exactly 1 means either variable capital A, either only variable capital A or only variable capital B, right? There should be exactly one variable present, not less than 1 and not more than 1. Only one variable should be present. Out of these 4 regions, if I look at small n, there is no variable present. If I look small g, there are 2 variables present. If I look at variable small a, there is only one variable present. And if I look at region small b, there is only one present. So exactly 1 means small a plus small. Same way, if I ask you exactly 2, what does this exactly 2 signifies? Exactly 2 signifies, right, where both variables are present, where exactly 2 variables are present, and that region is small. So altogether you can say total capital T is nothing but exactly 1 plus exactly 2 and plus none. Alright, total capital T. Now, in the end, you can say capital A plus capital B, the mathematical sum of A and B, the arithmetic sum of A and B. So, A is this and B is this. If you add both, you will get A plus B plus 2G but a plus b is exactly 1. So this is exactly 1, and plus twice of g is twice of exactly. We have to remember these sort of things, right? There could be at least 1, at most 1, at least 2. Such sort of language can also be there. So we can easily find that. All right. So this is all about two variables Venn diagram. Let's make the number of variables to 3. Number of variables is 3. How many regions will be there, right? So this is simple technique. See, number of variables is equal to 3. So number of regions. Actually, number of regions is 2 raised to the power number of variables. So this will be 2 power 3 is equal to 8. Number of regions is 2 raised to the power number of variables. So 2 power 3 is 8. Which regions? Small a, small b, small c, d, e, f, then g, then none, and this total is capital T. So how many regions are there? A, B, C, D, E, F, G, and N. These 8 regions are there. This is capital A, this is capital B, and this is capital C. Let's say tea, coffee, and cold drink. Now we are conducting survey over the likings of people among tea, coffee, and cold drink. So there are 3 beverages, basically. A, B, and C we can say, right? So here you can say capital A is, what is capital A? The entire circle. Capital A is A, D, F, and G. A, D, F, and G. Same way capital B is B, D, E, and G. Then capital C is C, E, F, and A, B, C. If you get to know A and B, what is A and B? A and B. So the region where A and B both are present. So D plus G. But if I ask you only A and B, there is a difference between A and B and only A and B. And what's that difference? So that difference is, in case of only A and B, we have to stick to A and B only. There can't be any third variable present. So only A and B means small d. Because G includes variable C also, but we have to stick to only A and B. That means we have to exclude G this time. Alright. So only A and B means small. If I ask you A or B, or means, right? A or B, or means, right? So in this case, we have to consider those reasons where A present, B present, right? Third variable can be present or may not be present, but at least one of A or B should be there. A or B means at least one of A or B should be there, at least one. So A or B means this reason we are talking about. This reason. This is A or B. So we will exclude only small c and small n. Alright. I hope you got this point. So this will be equal to small a plus small b plus small d, e, f, and plus small g. Or this will be equal to total minus only small c and minus only small. Both ways you can look at it. Okay. A or B. If I ask you only A or B, in this case, we have to exclude third variable C. So this will be small a plus small b plus small d. We have excluded E, F, G because of variable C. All right. Next, total is none plus exactly 1 plus exactly 2 plus exactly 3, right? Exactly 1 is small a plus small b plus small c. Exactly 1 means only variable a plus only variable b plus only variables. Exactly 2 means only variable a and b plus only variable b and c plus only variable a and c. So this will be d plus e plus f. Okay. And exactly 3, this is small g. None is n. All right. Now, if I add a plus b plus c, b plus c, so basically you are adding these variables here. So a plus b plus c will give you exactly 1 plus twice of exactly 2 and plus thrice of exactly 3. Okay. Next. So next we will discuss few questions based upon 2 variables and 3 variables, and after that we will come to the fourth section of this lecture, and that will be 4 variables Venn diagrams. Alright, now let's come to the questions and apply this understanding in the questions. So this is question 1. In a class 72 students like only maths, 50% of the students like science, 25% of the students like both maths and science, and 5% students like neither maths nor science. This is the information, and after adding this information we can say this question is of 2 variable Venn diagrams, right? So this is a 2 variable Venn diagram. Here we have one circle representing maths and other circle representing science. Okay, maths, science, and we have total also, total. Okay. Now it says 72 students like only maths. So this region is 72. Only maths is 72. 50% of the students like science. So the students who like science. See here the only word is missing. 50% of the students like science. Here 72 students like only maths. There is difference between these two phrases, right? In one case there is only maths and in the other case there is science. So only maths 72 we have placed here, but 50% will be placed outside the circle of science. 50%. Okay. 25% of the students like both maths and science. 25% students like both maths and science. Can I say out of 50% students who like science, if 25% students like both maths and science, then the number of students who like only science will be 50 minus 25, 25%. I hope this is clear. Out of this 50, this 25 is here. So remaining 25 will be here. All right. So 25%. Next, and 5% of the students like neither maths nor science. None is 5%. So can I say if total student, obviously 100% is the total number. Out of 100%, 5% is none, 50% is science. Can I say remaining 45% is maths? Alright, 50% is here. Only maths will be 45%. 50 plus 5 plus 45 is 100, right? Now, so you can say 45% of total students is 72, and we know 45% is, right, 9 by 20 of total students. 9 by 20 of capital T is 72. 45% of capital T is 72, so 9 by 20 in terms of fraction. 9 by 20 of capital T is 72, so capital T is 160. You can say 100% of this number or 100% of total is what? 160. Now come to the question. Total students of the class 100%, 160, right? How many of the students like only maths or only science? Only maths or only science means is asking for exactly 1. Only maths or only science means 45% here plus 25% here. 45 plus 25 is how much? 70% and 70%. So if 100% is 160, then 70% is 112, right? If 100% is 160, then 70% is 112. How many of the students like neither maths nor science? Means 5%, and 5% will be 8. Option C. How many of the students like only science? Only science means 25%. If 100% is 160, 25% is 40. Option D. How many of them like at least one of the two? At least one of the two means total minus none. At least one of the two means exactly 1 plus exactly 2. So can you look at it in other way? That is total minus none. Total is 100%, 160, and none is 5%. 8, 160 minus 8 is 152. Option D. I hope this question is clear to everyone. Now we will jump to the next question. It says 80 people in a colony were surveyed, and it was found that for every 6 people who play badminton, there are 4 people who play hockey. For every 9 people who play badminton, there are 3 people who play both of them. Further, the number of people who play both of them is same as those who play neither of them. This is the information we have. Now, as per this information, there are 2 variables. One is hockey and one is badminton. Again, we are going to draw a 2 variable Venn diagram. One of the circle represents people playing badminton, and the other circle people playing hockey. Okay, and here we have total, right? So 80 people in a colony means this total is 80. First thing, total is 80. Next, and it was found that for every 6 people who play badminton, there are 4 people who play hockey. Means if badminton is 6x, hockey is 4x. If badminton is 6x, hockey is 4x. Okay, next statement. And for every 9 people who play badminton, there are 3 people who play both of them. If badminton is 9y, then both is 3y. See, we will do one thing here. This is just assumption of variable in a best way possible. So badminton is 6x, 9y. Let's think of some number that is multiple of 6 and 9, which is 18. Can we think of badminton as 18 times k? Let's say 6x or 9y. Let's forget the 6x or 9y. We are considering badminton as 18k, which is multiple of 6 and 9, 18k. This will solve our purpose. After this, story will be very simple. See now, for every 6 people who play badminton, there are 4 people who play hockey. Means if badminton is 6, hockey is 4. If badminton is 6 into 3, 18, hockey is 4 into 3, 12. So now this will be 12k. Easy. Next, for every 9 people who play badminton, there are 3 people who play both. For every 9 badminton, there are 3 for both. 9 into 2, 18, 3 into 2, 6. So both will be 6. And now after this story is very easy. Out of 18k badminton, 6k is both. Can I say 12k is only badminton in that case? 18 minus 6 is 12. Out of 12k hockey, 6k is both. So out of 12k, if we subtract 6k, remaining will be 6k. Means only hockey is 6k. Last statement says the number of people who play both of them is same as those who play neither of them. Both is 6k, none will be same, 6k. Small n is equal to 6k, right? Now, after this, if you add all these numbers, so 12k plus 6k plus 6k plus 6k, so 6 is 18 plus 12 is 30k. 30k is 80. Now you have 30k is equal to 80 can I say K is equal to 8 by 3? 8 by 3. Now, question 1 says, how many people like only hockey? Only hockey is 6K. So 6 into 8 by 3. 6K is 6 into 8 by 3, which is 60. So option C. How many people play badminton and hockey? Badminton and hockey means this reason it is asking about 6K, right? And 6K again 16. 6K, 6 into 8 by 3, 16. How many people play only badminton is 12K, so 16 into 2, 32. If 6K is 16, 12K is 32, right? Now, come to question 4 and question 5. These are little bit tricky questions, okay? Tricky, or you can say a bit calculation intensive. If 12.5% of the people who play both of them, how many people are there currently who play both of them? This is 16, right? Stop playing badminton. If 12.5% of these 16 people stop playing badminton, then what percentage of the total number of people play badminton, right? As of now, currently, total number of people who play badminton is 18 into 8 by 3, right? 48. 18 into 8 by 3 is 48. All right. So currently 48 people are playing badminton. How many are stop playing badminton? So 16, 12.5% of 16, 12.5% is 1/8. 1 by 8 times 16 is how much? 2. So 2 people are stop playing badminton. So out of 48, if we subtract 2, remaining will be 46. That means 46 people will play badminton. 46 out of 80 is what percent? 46 out of 80 into 100. If you solve this, we're getting 57.5% straight away. Alright, 46 people will be playing badminton after 2 people stop playing badminton, right? So 46 and out of total people 80, this percentage is 57.5. I hope this is clear. Forget this story. Come to question 5. If half of the people who play only badminton is how much? 12K means 32. If half of 32 stop playing badminton and start playing hockey, means out of this 12K, you are saying this 12K, there are 6K who stop playing badminton. So remaining who play only badminton will be 6K, and the people, the 6K people who stop playing badminton are now playing hockey. So after that you can say that only badminton 6K, only hockey 12K, and both 6K and none 6K. This will be the story, right? Then what is the total number of people playing badminton to those playing hockey? Total number of people playing badminton will then be 6K plus 6K, 12K, and with that of hockey 6K, 6K is 12K, and plus 6K from both, 12 plus 6 18K. So 12K ratio 18K is 2:3 will be our answer. Okay. Now come to this next question. It says, in Gokuldham society, a survey was conducted among 300 people to find the consumption of 3 beverages: tea, coffee, and cold drink. Right? Total 3 variables are there: tea, coffee, and cold drink. It is known that 100 people consume at least 2 of these beverages. 230 people consume either tea or cold drink. 180 consume exactly one among the 3. And then 2 more statements are there: 80 consume neither tea nor coffee, and 130 consume tea or coffee but not cold drink. So this is the information based upon which we can say we require a 3 variable Venn diagram. Okay, so this is a 3 variable Venn diagram, right? Here we have a 3 variable Venn diagram. Okay, now so we have tea, right? Tea, coffee, and cold drink. So this circle represents tea, this represents coffee, and the next circle represents cold drink, right? Total is how much? 300. Total is 300. it says it is known that 100 people consume at least 2 of these beverages. See, while solving questions of Venn diagram, and particularly when we are solving questions of 3 variables and 4 variables, we do not assume variables as A, B, C, D, E, F, G, N. This will be a very lengthy process. Rather, we think in terms of exactly 1, exactly 2, exactly 3, none, exactly 4. We think in these terms so that number of variables is lesser, right? And lesser the number of variables, less is the solving time. I hope you got this point. We think of reducing the number of variables. So instead of thinking in terms of A, B, C, D, E, F, G, right? You have to think in terms of none, exactly 1, exactly 2, exactly 3, exactly 4. In these terms you have to think, right? So we will solve this question using these terms only. It says 100 people consume at least 2 of these beverages. At least 2 means exactly 2, exactly 3. So it says exactly 2 plus exactly 3 is how much? It is 100. Same way you can say none plus exactly 1 is 200. Why we are able to say this? Because total is none plus exactly 1 plus exactly 2 plus exactly 3. If exactly 2 plus exactly 3 is 100 and total is 300, that means remaining part none plus exactly 1 is 200. I hope this makes sense. Next statement, 230 people consume either tea or cold drink. 230 consume either tea or cold drink. That means only coffee plus none and plus this 230 will make total 300. You can say total, right? 230 plus only coffee. I am just writing only coffee and plus none. 230 plus only coffee plus none is 300, right? So in that case, none plus only coffee will be 70 plus only coffee will be 7. Now, next statement, it says 180 consume exactly 1 among the 3. Exactly 1 is 180, so none is 20. None plus exactly 1 is 200 and exactly 1 is 180. That means none is 20. If none is 20 and none plus only coffee is 70, that means only coffee is 50. So only coffee is 50, none is 20. And exactly 1 is 180. Exactly 2 plus exactly 3 is 100 and total is 300. Now we have these things. Last statement says, okay, 80 consumes neither tea nor coffee. 80 consumes neither tea nor coffee, which means only cold drink plus none is 80. None plus only cold drink is 80. Only cold drink is 80. Why? Because these 80 people, right, likes consume neither tea nor coffee. If we have to think of outside the circles tea, coffee, then there will be only 2 reasons left, only cold drink and only none, right? So none plus only cold drink is 80 and we already know none is 20. That means only cold drink is 60. So let's put this number 60 here. Now next statement, see, we have exactly 1 equals to 180. Exactly 1 will include only tea, only coffee, only cold drink. If only coffee is 50, only cold drink is 60. 50 plus 60, 110. And exactly 1 is 180. So this will be 7. 110, 180 minus 110 is 70, right? 130 consume tea or coffee but not cold drink. 130 consume tea or coffee but not cold drink means this region plus this region plus this region is 130. So this will be 10. Okay. 130 consume tea or coffee but not cold drink. So tea 70, 50, 120. So this will be 10, right? only tea and coffee will be 10. Now, come to the questions. First question says, how many people consume at least one of the two beverages? This word you have to correct. People consume, right? There is space. There is no space. Okay, fine. So, how many people consume at least one of the other two beverages along with cold drink? Uh, this question is asking for those people who are already consuming cold drink but consume at least one other beverage. So maybe cold drink or tea, maybe cold drink or coffee, right? So basically we have to find this, this and this. These three reasons we are finding. So these three reasons along with this number 10 will be nothing but exactly 2 plus exactly 3. But we are not looking for this number 10. That means 100 minus 10. So our answer is 9. We are not looking for this number 10. Rest three regions we are looking. So 100 minus 10 is 9. How many of the people consume all the three beverages? Using this information, we are not able to determine exactly 3. So our answer is cannot be determined. And the last question, how many people consume only tea? Only tea is 70 here. So our answer for this question will be 7 for the last question. Okay. So I hope this question is also clear to everyone, right? Now we are moving to the fourth section of today's lecture, and that section is 4 variables Venn diagram. Learn how to plot this 4 variable Venn diagram. Okay, this is the structure of 4 variable Venn diagram. This is the way how we draw. Okay, so this rectangle represents total t. How many variables, how many regions will be there? Variables are 4, so regions will be 2 power 4, means 16. The regions will be 2 raised to the power 4, which will be 16. Okay, there is variable capital A, capital B, variable capital C, and last variable capital B. Okay, only variable A, small a, only variable B, small b, only variable C, small c, only variable D, small, right? Then we have only A and B, E, only C and D, F, only A and C, G, only B and C, H, only B and D, I, only A and D, J, right? Then we have 3 variables, exactly 3. So A, B and C, K, B, C and D, L, A, B and D, M, A, C and D, N. And this all 4 is O. And outside none is, let's say, P. None is, okay. So we have total how many regions? 16 regions. So A through P are the total 16 regions. Okay. Now, see, how will you get this? That this region is what? What this region is denoting here. So look for the intersection. Like this region made up of which variables? Is variable B here? No. Is variable D here? No. Is variable C here? Yes, of course. Is variable A here? Yes, of course. So this small g is nothing but only A and C, right? This is intersection of 3 variables A, B and C. So you have to look, right? Properly. Now, story is same here also. A is A, E, G, K, N, O, J, M. B is E, B, K, H, O, L, M, I. Right? This way you can think of. Okay. If I ask you A and B, and so A and B is E, K, O, M. EKOM. I hope you can easily understand these things now, right? Only A and B is small e. This also. If I ask you only A and B, only A and so this will be what? Small, right? What about exactly one? A, B, C, D. A, B, C, D, right? Exactly two is what? E, F, G, H, I, J. Exactly three, K, L, M, N. Exactly four, O, right? This is not zero. Exactly four is O. O is the variable, right? Total is none plus exactly one plus exactly two plus exactly three and plus exactly 4. This is total. And if we add A, B, C, D, this thing you know, A, B, C, D, this will be exactly 1, twice of exactly 2, thrice of exactly 3, and 4 times exactly 4, thrice of exactly 3, right? And 4 times exactly 4, right? Okay. So this is 4 variable Venn diagram, right? Rest of the things at least one variable, yeah, at least two, at least three, at least four. These things you can easily understand while solving the questions. Okay. Come to this question. A survey of 600 schools in India was conducted to gather information about their online teaching learning process (OTLP). Right. Following four facilities were studied: F1, F2, F3, and F4. F1 denotes on software for OTLP. F2 trained teachers for OTLP, F3 training materials for OTLP, and F4 all students having laptops, right? So these are the four variables. Basically, we need four variable Venn diagram, right? Let's stand here. So this is the four variable Venn diagram. Total is how much? Total is 600. Okay. Next thing, F1. This is F1. Then we have F2. We have F3. Last we have F4, none is also there, right? None O is equal. Okay. Now it says 80 schools did not have any of the four facilities, so none is 80, right? Okay. You might be confusing, so I am writing it NONE, right? None is 80. 40 schools had all four facilities. All four is 40. This reason is 40. Okay. The number of schools with only F1, only F2, only F3, only F4 was 25, 30, 26, 20 respectively. Only F1 25, only F2 30, only F3 26, and only F4. Okay. Now next, the number of schools with exactly three of the facilities was the same irrespective of which three were considered. It says wherever is the region exactly 3, the number will be same, irrespective of which three variables are involved. So there are four regions K, L, M, N. Each of the four will be same. So this is X, this is X, this is X, and X. Each region will be same. 313 schools had F2. 313 schools had F2. Among the 26 schools had only F2 and F3, but neither F1 nor F1 nor F4. 26 only F2 and F3. 26. Okay, this number is 26. Among the schools having F4, 24 had only F3. Among F4, 24 had only F3. So this number is 24. Basically only F4 and F3 is 24. And same way only F4 and F2 is 45. Only F4 and F2 is 45. Okay. Next, 162 schools had both F1 and F2. Had both F1 and F2 is 162. That means this region, this entire region, this one is 162. This one basically. This is 162. Okay. Now, as of now, I'm noting it like this. This is 160. Okay. Next, the number of schools having F1 was the same as the number of schools having F4. Total of F1 and total of F4 are same. Okay, fine. Now, let's first utilize this information 162. Can I say this total is 330? This total is 330, right? So, and this one is 162. Okay. Can I say 162 plus 30, 26, 45? 30 and 26 is 56 and 45 is 101. So 162 plus 101 and plus x is 313, right? Is 313. From this you can say x is how much? So x is 313 minus 263, x is 50. Okay, so number x is 50. This is first thing, just replace x by 50. X is 50 beta. Okay, so these four regions you can find. This is 50, 50, 50 and 50 each. Out of this 162, 50, 40, 50 here, then this region only F1 and F2, only F1 and F2 will be how much? So 50 plus 40 is 90 plus 50 is 140. Out of 62, 140 is there, so this will be 20, right? 162 minus 140, so this is 20. We are left with only two regions now. The region where this only F1 and F3 is there and only F1 and F4 are there. Let's say this region is Y and this region is Z. Okay. Now, total of F1 is equal to total of F4. So, total of F1 is equal to total of F4. Let's add F1. While adding F1, we will use this 162. This is the easiest way, right? So already 22, 50, 40, 50. This is 162. Then plus 162 plus 25 is 187, and plus 50 is 237. So 237 plus y plus z. Okay, 237 plus y plus z. This is F1. And what about F4? And what is reason F4? So F4, add all these reasons. 50 plus 40, 90 plus 50, 140 plus 24, 164 plus 20, 184 plus 50 and 45. 184 plus 50 and 45 is 279 plus z, from which you can say y is 42. Okay, y is 42. Now this total region is 600. So use this total 600. 600 must be equal to 313. This number is already there, 313. Y to add individually. So this is 313. Then we have 25 plus y is 42 plus 50 plus z plus 25 plus y is 42 plus 50 plus z plus then this number 26, 2450 plus 2070 plus 80, 150. Using this, you will get value of z. So z is equal to 600 minus 313 and 42. Let's add these two numbers first. 313 plus 42 is 355 plus 25 is 380 plus 50 is 430 plus 150 is 580 and 600 minus 580 z is okay. So y is 42, z is 20, right? Now we can answer the questions based upon this information. This region is F1, okay, F1. We have y as 42 and z as 20. This y is 42, z is 20, and total is how much? 600. Question 1 asking for what was the total number of schools having exactly 3 of the 4 facilities. Exactly 3 of the 4 facilities means 50 plus 50 plus 50 plus 50. All the values where x was there. So 50 into 4 is 200 will be our answer, right? Next, what was the total number of schools having facilities F2 and F4? F2 and F4 facilities. F2 and F4. So basically we have to find the sum of these 4 regions. F2 and F4. So 40 plus 50 is 90 plus 50 140 plus 45 is 185. Okay. Next, what was the number of schools having only facilities F1 and F3? Only facilities F1 and F3. So this is Y and Y is 42. And last reason, only facilities F1 and F4. Last question. So this is Z. The number is 1. So I hope all the questions that I have covered are clear to everyone. If you have any doubt, any queries you have, you can post in the comment box. I hope this is clear. Now, in the next session, we will cover some other topic of logical reasoning. Till then, bye bye.